Hi dear students, today we are going to discuss a new question. As I have attached the question, you can observe that this is our question part. That means we have been given a matrix, that is this matrix, that is 0 minus tan alpha by 2 plus tan alpha by 2 and 0. We have to prove that I plus a is equal to I minus a times of this matrix what we have given here. Okay, so let's start to prove that. But before proving that, I will give you some identities of trigonometric identities, what we can say, uh, that are, we know that this formula sine 2 theta can be written in the form of a 2 tan theta upon 1 plus tan square theta. Using this identity, I have found the value of sine alpha by alpha, because when you replace this 2 theta by alpha, you can observe from that. I'm here doing a rough work for you. When we replace this 2 theta by alpha, that means what? That means here we have 2 times of alpha by 2 I can write. When you multiply this, you get sine alpha again here. Now using this identity, in place of theta, we can assume that this is our theta. So after assuming this, when you put this theta into this, you get 2 times of tan alpha by 2 upon 1 plus tan square alpha by 2. Okay, and you can observe this is the identity what we have here given. Okay, similarly we have evaluated the cos alpha using the cos 2 theta formula. Okay, after just not evaluating, after giving these two definitions, or we can say that these two properties, now we are going to find the left hand side of the equation 1 what we have to prove. Okay, so find the let's find I plus a, that is I plus a. Here I is nothing but it's an identity matrix I, this I, and you all know the identity matrix, that is 1 0 0 1 of 2 cross 2 order, and A is the matrix what we have given in the question, so we have put it here A. When you add this matrix, 1 is added to the 0, we get 1, 0 is added to the minus tan alpha by 2, we get minus tan alpha by 2, and again similarly 0 is added to the plus tan alpha by 2, we get plus tan alpha by 2 here, and 1 is added to the 0, we get 1. So I plus A is found to be this, and we have supposed that this is our equation number 2. Okay, later we will use it, so I have noted it as equation 2. So let's move for the right solution of the right hand side part. So in the right hand side, you can observe that here is we have I minus a. So I'm going to evaluate the I minus a value. I is nothing but again our identity matrix. So I put it here, identity matrix. And here is we have a sign of minus, I minus, and the matrix A. When you subtract 1 minus 0, we get 1 here. When you subtract minus ka tan alpha by 2 from 0, we get plus ka tan alpha by 2. Why? Because this minus gets multiplied to this minus, we get plus ka tan. Okay. Similarly, 0 is subtracted from tan alpha, it's not 0. Tan alpha by 2 is subtracted from 0, we get minus ka tan alpha by 2. Similarly, when we subtract 0 from 1, we get ka 1. Okay. So this is what we get here. Now let's move to the second part, that means second page. So, okay, now you can observe from the previous page, we have to evaluate on the right hand side this part. That means the product of these two matrices. So I'm going to the product of these two matrices. Okay, but before producting them, I'm going to replace this cos values and sine values into the tan form, what we have here noted. Okay, as given as a note, I'm using it. After using this, you have to just replace the values what I have written here. Just I have replaced, nothing else. Okay, sine alpha is replaced by this value. You can observe this, sine alpha is replaced by this value, sine alpha is replaced by again this value here, cos alpha is replaced by this value what we have written in the note part of the page 1. Okay, now we are going to the product. So let's product them. So let me just change my color. Okay, so let's move to product them. When we product, 1 is producted to the first part of this. Okay, when we product 1 to this, we get this part only, and plus when we multiply tan alpha by 2 with the second part, what we get? We get plus ka 2 times of tan square alpha by 2. You can observe, because this tan alpha by 2 is multiplied with this upper tan alpha by 2 and lower part with the as it is. So we get this. Similarly, when we multiply this a1 with this part, we get minus ka here. Okay. Similarly, when we multiply this tan alpha by 2 to this second part, we will get 1 is multiplied. This 1 is multiplied with the tan alpha by 2. So here we have tan alpha by 2 and minus this minus sign is here. And tan alpha by 2 is multiplied with 10 squares, we get 10 cube alpha by 2, and denominator part is as it is what we have given. Similarly, we are going to multiply the second part of this, that is minus tan alpha by 2 is multiplied by the this part. When we multiply minus tan alpha by 2, this 1 will get minus tan alpha by 2, and this minus of 10 square part gets plus, and it will get cube because here is a 110 and here is a 210, 10 square I mean, so we get 10 cube alpha by 2, and denominator part is as it is what we have given in this part. So again, when we multiply 1 to this part, what we get? We get as it is this part here. Okay. Now we are going to multiply this tan alpha by 2 minus to this minus, and this minus into minus will get plus here, and here is tan alpha by 2 and here is 210. So here 2 times of tan alpha by 2, and when you multiply, and denominator part is as it is here what we have given. Again, when you multiply this 1 to this, you get as it is. Okay. After doing all this thing, you can observe from here that I'm going to just describe one part of this and one part of this, so that we can move to the next page. So you can observe that these two parts are similar. I mean, denominator parts are same. So I can take common. So I can write it as this one part. I'm just explaining you. 1 plus 10 is square alpha by 2. When we take in denominator as a common, the numerator part will get added. When we add them, what we can observe? This is a 2 times. This is a minus 1 times. When we add, we get plus ka 1 times. So we get 1 plus 10 square alpha by 2 part. Okay. So while we were solving it, let me just change the color. While we are solving this part and this part, because they both are same part, we get this value. Okay. Okay. And now we are going to I'm going to explain you one of this part, that is they both are same actually. Okay. So I'm going to explain one of this part. So you can observe that the denominator is same again in this part. So I'm taking the denominator as a common, that is 1 plus 10 square alpha by 2. I'm taking denominator as a common. So when we add this numerator part to this numerator part, here is we have 2 times and here is we have minus ka 1 times. When you add these 2 times, we get plus ka 10 alpha by 2. Okay, 1 times, because this 2 is subtracted from 1, we get 1 again. And here we have 10 ka cube, so we have plus ka 10 cube alpha by 2. Now we can take 1 10 alpha by 2 common from the both parts. Okay, so I have taken one common, 10 alpha by 2 common from here. So what we get? We get 10 alpha by 2 is outside, and inside 1 plus 10 square alpha by 2. That means similar part of this. So I'm going to the next page. So let's move. So you can observe that what we have solved previously, we have written here. For this part, you can just let me again change the color so you didn't get confused. Okay, when we solve this, we have found this. Okay, so I have put this value here. You can observe similarly. Okay, and also I have put this value here because as I told you previously that they both are same. You can observe them also. They both are same. Okay, so I have solved this and I have put this value what we have done in the both these places. Now, and we have solved this part and they both were same. So after solving we get this, and I have told you that just take 10 alpha by 2 common from the numerator part. So I have taken here 10 alpha by 2 numerator from common. Okay, we get this part upper part and then lower part this, and here we have a minus sign. Can you observe why? Because in this upper part we have a minus is we can, when you solve we get minus ka, because minus is 2 here, and here we have plus ka 1. When you add this, we get minus ka 10 alpha by 2, and here you are also minus. So we have taken minus common, so we get this minus also here. Okay. Now, after solving this, we have found this, and taking 10 alpha by 2 common from it, we get this part. Okay. Now we can observe that these numerator and denominator are same in the first entry, so we can cancel out them. We get 1 here. Similarly, here if they will cancel out, we get 1 here. They again get cancel out, we get 1 here. Again they can cancel out, we get 1 here. So just simplify them and write what we get. Here we get 1. Here we get minus ka 10 alpha by 2, we have written minus ka 10 alpha by 2. Here we get plus ka 10 alpha by 2, we have written here 10 alpha by 2. We have 1 and we have put it here 1. That is nothing but I plus a. You can observe what we have written to the equation number 2. Yes, this is our equation number 2. You can observe that 1 minus ka 10 alpha by 2, 10 alpha by 2 and 1. That is what we require to prove, and hence we are done. Okay, that's all for today. Have a good day.